All right, 6.1. In this lesson, we're going to use properties of exponents to simplify expressions. Before we talk about those properties, thing we need to know. So if we have something a to the m power, okay, the a, that is our base. The number that's the superscript, that is our exponent. Okay, so know those terms. A is the base, m is the exponent. Okay, so those properties that we have product of a powers property. That is saying when we're multiplying two terms that have the same base, we are going to add the exponents. Okay. Power of a power, we're taking a term that has an exponent to another power. Okay, so we got m to the n, and then in those cases we multiply the exponents. Okay, power of a product property, so that's saying we have a term inside that we're saying a times b to the m power, that whole thing to the m power. We're going to take that exponent to both terms inside of the parentheses. Okay, negative exponent property, if we have a negative exponent, the way we take care of that is we bring it to the bottom. Okay, that term to the bottom. So in this case, we'd have 1 over a to the m. All right, zero exponent property, anything to the zero power will equal 1, no matter what the base is. Okay, a cannot be 0 though, because 0 to a power, we're not going to be able to do that. All right, quotient of a power. So we got a to the m over a to the n. In those cases, when we're dividing two terms that have the same base, we are going to subtract the exponents. And then power of a quotient. Okay, we've used these to simplify already. So we got a over b, that whole thing to the m power. We're just going to take that exponent to both terms inside the parentheses. Okay, so we'll go through these. You will need to understand these properties. You don't exactly have to memorize that, but you need to know how they work. Okay, so let's just go over a couple of them a little more in detail. That negative exponent property. Okay, that negative exponent property is a to the negative n. Okay, so whenever we see that negative exponent, we're going to bring it to the bottom, and then that's going to make the exponent positive. So let's just look at an example. Let's say like 3 to the negative 2 power. Okay, we have that negative exponent, so we're going to bring it to the bottom. And then from there, if it's a value like that, we can simplify that. All right, now, let's say that negative exponent is in the denominator. So let's say 1 over 3 to the negative 2. Okay, same idea, except now instead of bringing it to the bottom, we're going to bring it to the top. So then in this case, we would just have 3 squared over 1, which is just 3 squared, so 9. All right, zero exponent property. So that's the one where the base is to the 0 power. In that case, it is always equal to 1. So we could have 46 to the 0 power. Okay, again, it does not matter what that base value is. Anything to the 0 power is 1. I could have x, y, z to the 0 power. Okay, I don't care what the exponents are. We're taking it to the 0 power, therefore it is equal to 1. Okay, now there is a difference. If I was to say this x times the quantity xy, let's say yz, to the 0 power, this one would be a little different, because this right here, the yz to the 0 power, that is 1. So that would be saying x times 1, which in this case would be just x. Another one, let's say negative x to the 0 power. Okay, when we're doing this, we have to think of this negative and x as two separate terms. Because I could write that as negative 1 times x to the 0 power, therefore negative 1 times 1. So in that case, it would be negative 1. Now, if I was to say negative x, that quantity to the 0 power, that is a case where it would be 1. Okay, so it's very important to understand where the parentheses are. Okay, so that was our zero exponent property. We'll go through those a little more here later on. Okay, if you need to go to the book, okay, all those properties are on page 323. Okay, on the notes, I'll have them spread out throughout the whole notes, so you can always refer back to those as well. All right, so let's go to some expressions and let's simplify them. So in the first one, we got x to the fourth times x squared. Now, we have the same base, and we are multiplying. Therefore, we're going to be using the product property. We are multiplying. And when we multiply those two terms, we are adding the exponents. Okay? So in this case, we're going to have x to the 4 plus 2, which gives us x to the 6. Now, let's break this down. X to the fourth, if I expanded that, that's saying x times x times x times x. Okay? Times x squared, which I can write as x times x. Okay? So now we're just saying x times x times x 6 times, which we would write as x to the 6. So that is how that property works. All right. Now, number 2 here. Okay, this one's looking like a power of a power. Okay, we're taking x cubed, that whole thing squared. So in that case, we take x and we multiply the exponents. So in this case, x to the 6. Now, the way this one works, we got x cubed, which we would write out as x times x times x. Okay, squared, say we're taking that same term, x times x times x. And therefore, we have 6 x's that we're multiplying, so x to the 6th. All right, number 3 there. 3x squared, so that's saying 3x times 3x. Okay, so in that case, it would be 9x squared. Okay, if we look at our properties, that's a power of a product. Okay, and again, we're taking that exponent to both a and b. Okay, in this case, 3 is like your a, x is like your b. So if you want to write it out like that, it'd be like 3 squared, x squared. Simplifying that 3 squared, you get that 9x squared. Okay, power of a product. Okay, quotient, no, quotient. They have the same base. So quotient right here, a to the m over a to the n is equal to a to the m minus n. Okay, so what we're doing here is we are subtracting the exponents. So x to the 5 minus 2, which would give us x cubed. So let's break this down and expand it again. X times x times x times x times x. That's x to the 5th. X squared. Okay, since we are multiplying all these, it's just like terms are canceling. And we're left with 3 x's. So therefore, x cubed. All right. X cubed over x cubed, still a quotient again. So we could say 3 minus 3, which gives us x to the 0 power. There again, we got anything to the 0 power is equal to 1. So we'd have to apply the 0 exponent property there as well. Okay, and again, if you expanded that, x top is the same exact as the bottom, so that's a case where it is equal to 1. All right, now, okay, still a quotient. Using our quotient property, we'd do 3 minus 5. It is always the top exponent minus the bottom exponent. So in this case, we would get x to the negative 2. Now, this is a case where we have to use the negative exponent property. Okay, so we got to use a couple properties in this case, in which case we would be 1 over x squared. Now, if you expand it out, that's saying x times x times x on top, x times itself 5 times on the bottom. Okay, cancel, 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 and you're left with 2 x's in the bottom, so 1 over that x squared. All right. So there we use the properties, and I expanded everything out just to give us a better visual. All right, so let's start dealing with some numbers then. These properties still apply even when they are numbers. Okay, so in letter A, we got a power to a power. In those cases, again, we multiply the exponent. So that's saying 3 to the 4 times 2, which would be 3 to the 8th. Now plug that into your calculator. You're going to get 6,561. Okay. So if it is a base value that is a number, you can simplify that and write out that number. So, all right, 5/8 to the 3rd power. Okay, that's power of a quotient. Okay, so again, we're taking that exponent to both the 5 and the 8. So that's going to say 5 cubed over 8 cubed, which will simplify to 125 over 512. All right. Now, letter C here, a little bit more tricky, okay? So, really, it's actually not. We're looking at our base values, okay? Our base values are -2, okay? So, our base value is -2, and we are multiplying these terms, so we're going to add -3 plus 9, which will give us -2, that quantity, to the 6th power. Now, we are taking it to the 6th power, okay? So, well, let's break this down. This is saying -1 times 2 to the 6th. So we can say -1, that quantity, to the 6th power, times 2 to the 6th power. And since we are taking it to an even power, okay, so we're multiplying a -6 times, which will give us a positive. So our answer in the end will be positive. So all we really need to do is do 2 to the 6th, which will give us 64. Okay. All right. Last one here, 3 and 1/3 squared. Whenever you get a mixed number like this, what you need to do is you need to change it to an improper fraction. So remember, we got 3 wholes, so we're going to multiply 3 times 3, and then add that numerator, which will give us 10, and the denominator stays the same. So then we got that power of a quotient again. So 10 squared over 3 squared, which will give us 100 over 9. Okay. I typically see a lot of mistakes on that. You need to remember to change it to an improper fraction. If not, it is not going to work. All right, so let's get into some that require using multiple properties. Okay, so letter A there. You got a squared over b to the -3rd to the 3rd power. Okay, so again, we have a power of a quotient. So we're going to take that 3 to both. Okay, and now since it's a squared, now it's a power to a power again. So we're using a mix of those two properties. That's saying a to the 2 times 3 over b to the -3 times 3, which would give us a to the 6th over b to the -9th. We got to use one more property, since you can never have a negative exponent in your simplified answer. Okay, so with that negative exponent, we need to bring that to the top, which will give us a to the 6th times b to the 9th. Okay, so in this one, we use the power of a quotient, power to a power, and negative exponent property. Okay, so a mix of 3 different properties there. All right, so in B, this one's pretty complicated here. So we got power of a product here. Again, when you get that -y squared, think of it as -1 times y squared. Okay, and we still got that y squared, y to the -12th. So now it's going to be -1 to the 5th, and y to the 2 times 5, which gets us 10th, 10. And we still got those other ones. So -1 to the 5th, that will be -1. And then we will have to add the exponents with the y's there. So 10 plus 2 plus -12. So then we're going to get -1 times y to the 0 power, which will say -1 times 1 for an answer of -1. Okay, a little more complicated than most others, but the big thing is just think of that as a power of a product. The -y squared, think of it as -1 times y squared. All right. C, we got rs squared over the quantity rs to the -1st cubed. So let's concentrate on the denominator there. Okay, let's just leave the rs squared by itself right away. Again, we got a power of a product, so we got to distribute that exponent of 3 to both r and s. So we got r cubed and s, and again, it's a power to a power, so we multiply to the -3rd. Now, whenever you're simplifying, okay, you should not have two of the same base on top and bottom. So since I have an r here and r here, we have more simplifying to do. Okay, so in this case, we got a quotient with the r's, so it'll be r to the top minus the bottom exponent. Same thing with the s, so 2 minus -3. When we simplify that, we get r to the negative 2, s to the fifth. Okay, we got to apply one more exponent property. We have that negative exponent. So we got s to the fifth over r squared. Now, the way I like to think about it, when I look at those r's, okay, I have more r's in the denominator, therefore r should end up in the denominator in my simplified answer. Okay. Now, when you're doing these, there's so many different ways you can go about it. It all depends on what property you like to work with. Okay. So the way I'm doing these, you don't have to do that, because I could have used the negative exponent property here, brought that up, so it had s squared times s cubed, and to add the s's, okay, so again, you still end up with that s to the fifth. Okay, so one more here. So again, we got a power of a product, power of a quotient, we got a mix of everything here. Big thing is we need to distribute that exponent of 3 to all of these exponents. And then in those cases, it's a power to a power, so we need to multiply those exponents. And when you look at it, b, that's saying b to the first. So when I do this, I'm going to get a to the 2 times 3, so a to the 6, b to the 1 times 3, so b cubed, over a to the negative 1 times 3, so a to the negative third, and then b to the 5 times 3, so b to the 15th. And again, we have a's on both top and bottom, b's on both top and bottom, so there is more simplifying to do. Now, again, you can go many different routes here. I could take care of that negative exponent, bring that up to the top right away, or just use the quotients. Okay, so let's go ahead. Let's use our quotient property. So a, the top exponent minus the bottom exponent, so minus negative 3. B to the 3 minus 15, which will give us a to the 9th, b to the negative 12th. There I have to deal with a negative exponent again. So we will have a to the 9th will stay on top, and then negative exponent, we bring that term to the bottom, so b to the 12th. All right, those are properties of exponents. Okay, the assignment for this section 6.1 book assignment. It is a little longer, but it is very important we get good at these. Okay, these exponent properties should come natural once you do enough of them. So make sure you do that homework. If you have questions, let me know. Otherwise, have a good day.